Good afternoon to everyone. Today class is my Bowen's reaction series. So this is very, very important to us. So, okay. Well, Bowen reaction series from igneous point of view, right? So it have to understand how magma it can convert into rock and what will be it will be what it will be order of crystallization of some various minerals within the range of temperature, right? So the first question is, who was Bowen and what did he do right? So you see this picture. So he is the Norman Levy Bowen, right? So the Bowen reaction series was developed by who? Norman Levy Bowen. So he was a Canadian geologist. So he is also known as the father of the petrology. Right? So father of the petrology. So that is the study of rocks, right? Study of rocks. So well, N.L. Bowen, Norman Levy Bowen, he was an experimental petrologist, right? So in 1990s, in 1990s, in 1900s, right? So in 1900s, so he did some experimental studies at the geophysical laboratories in Washington, D.C. Washington, right? This Washington, D.C. So he experimented in this geophysical laboratories in the Washington, D.C., right? So those studies were in order to understand the crystallization, right? So you remember this word, crystallization. I already told about this crystallization, how to crystal forms in igneous rocks, right? So those studies were in order to understand the crystallization of common silicate minerals. Silicate minerals from the basaltic magma, right? Basaltic magma. Basaltic magma, right? So common silicate seen from this basaltic magmas, right? So who was the Bowen? What did he do? So Bowen was a experimental petrologist and he begins experimental studies in 1900s at the geophysical laboratories in the Washington, D.C. And also it is to understand the order of crystallization of common silicate minerals from the basaltic magma, right? So for I go to Bowen reaction here. So the Bowen reaction series. So I assumed that all you know some terms like magma, right? So what are the different types of magma and what the terms which I will be using frequently during this class, right? So you see what is the magma? Magma is the molten rock material. So which is a mixture of liquids and crystals and also dissolved solids, right? So these are the molten materials and this is the definition of magma. So some types of magma you see here. So the types of magma, so those are determined by chemical composition. So you remember this one, chemical composition of the magma. So that is the three general types are recognized. First one is basaltic magma, that basaltic magma. And second one is andesitic magma. And third one is rhyolitic magma. So, like magma is molten rock materials, right? So, which is a mixture of liquid, crystals, and dissolved solids, right? So, types of magma, that means depending upon chemical composition, right? So, there are different types of magma. First one is basaltic, so which contains that is silica range, right? Silica range, that is 45 to 55 percentage, right? Weight. So, and high in iron, magnesium, calcium, in low in potassium, sodium, right? So, this is the basaltic magma. And second one is andesitic magma. So, andesitic magma, which contains silica, that silica range, that is 55 to 65, and intermediate, and in those are minerals have iron, magnesium, calcium, sodium, and potassium, right? And third one is rhyolitic magma. So this is also which contains silica percentage, that is 65 to 75 percentage, and that is low in iron, magnesium, calcium, and high in potassium, sodium. So these are the low minerals and these are the high minerals, right? In rhyolitic magma, right? So we need to keep these terms in your mind, right? So that how silica percentage is changes within these magmas, right? These three magmas. So you see this picture, this is the Bowen reaction series, like so this series it has two branches, right? You see here. So first one is continuous branch, and second one is discontinuous branch. Okay, so in this diagram you can see on the right side, right? So right side, this is the continuous branch series, right? So on the left it is the mineral reaction, that is shows discontinuous series, right? So you remember this two branches, continuous branch and discontinuous branch, right? So don't confuse this series. So in this Bowen series on the left, right? So in the order of crystallization, those are mafic minerals and ferromagnesium minerals, right? Mafic and ferromagnesium minerals. So, and you can see the diagram. So the right hand, right? So the right side is here continuous branch. This one continuous branch. So discontinuous branch. So those are order of crystallization of mafic minerals and ferromagnesium minerals, right? So in this continuous branch, so why is called continuous branch? First of all, so because the minerals along this branch, right? Along this branch, we have same basic structures like feldspar crystal structures, right? So, but along this discontinuous series, because one mineral changes to another. So, and during this process, the crystal structure also changes, right? So, the very new family of minerals, so that is, it will be appear here. So, and during this branch, continuous branch, the crystal structure is same, right? So, but the only changes appear in the element that is calcium rich and sodium rich, and also plagioclase, right? So, before I tell you more about Bowen reaction series, let us understand first what is plagioclase. Right? So the plagioclase, it is a solid solution of this series in feldspar minerals. So which as total 6 minerals that ranging from albite, albite to anarthosite, right? Sorry, anarthite, albite to anarthite. You see here. Okay. So these are the composition of mineral. So the anarthite, so this is calcium rich plagioclase, and which lies on the top of those are continuous branch, and it is crystallized in high temperature, right? High temperature. So, and gradually, which is to albite, this albite, so which is rich in sodium, right? Rich in sodium and crystallized. So that low temperature that is compared to anarthite, right? So this is high temperature and this is low temperature, right? So in between them, we can have a mixture of both of them. So it is depending upon the percentage of calcium and sodium in that particular type of minerals, right? What is that? Calcium, calcium and sodium, right? So this range, it may vary in between just anarthite to albite. So such as bitonite and which contains 70%, 70 to 90% of anorthite. It means calcium and the laborate that is 50 to 70%, right? 50 to 70% of the calcium and plagioclase, right? So plagioclase also we have 10 to 30%. That is of anorthite. And anorthite means calcium. So while it has 90 to 70% of sodium, it means we are changing the calcium to sodium rich minerals, right? So there are the minerals of discontinuous branch here up to biotite, like olivine, which is minerals of magnesium and iron, right? And which contains very less silica, So then the silica percentage increase in pyroxene. So that is compared to olivine, right? Olivine. So then it further increases in amphibole and biotite, and it last go to quartz here. You see here. So this one, quartz. So which is free silica. That means SiO2. So it does not contain any other elements or any other oxides. So this was all about the minerals, which we should know before understanding the Bowens reaction series, right? Okay. So as I told you that olivine and pyroxene, which are formed in high temperature, you remember this one, high, you see here 1400 degree Celsius centigrade, right? So this is a high temperature. So likewise, there are some plagioclase minerals which are formed at high temperature, which are calcium, right? Of course. So what happens with decreasing temperature? You see here lowest temperature here. So this decreasing temperature. So let's suppose we have a magma of basaltic nature, right? This basaltic nature. So with silica percentage is how much? 45 to 55%. So then it is how it crystallizes, right? So first, olivine, right? So olivine minerals will be formed, and likewise a calcium plagioclase, it will be formed here, right? And along this discontinuous series, so what happened after sometimes or after dropping some temperature? So this olivine mineral which was earlier formed, so it will no longer be come to melt here, right? So and so it will start reacting. So it will start reacting with the melt. So what happened? The new mineral will be formed in that is pyroxene, right? So you see here pyroxene. Okay. So let's see what is pyroxene, right? So this is so this pyroxene, it contains silica, silica and higher than olivine, right? Higher than olivine. So because gradually these are melt becomes rich in silica, and so pyroxene then react with the melting, so it will form amphibole. You see here amphibole. Okay. So and also amphibole will uh, form biotite, right? Biotite mica here. So by reacting with the melt, right? So along this branch, the calcium rich plagioclase, so that is those are formed and they will partially or completely react with the melt to form the intermediate plagioclase feldspar, or which is albite will be formed, right? Albite. Albite. Albite will be formed here. This albite. Okay. So this is the case of when the crystallization that is continuous. That means the minerals phases which are formed are constantly in contact with the some remaining minerals. So, but what happened in these minerals? Those are removed. So what the earlier formed phases, those are the removed from them. So it means no longer it contact with the melting. So which is the remnant melt. So suppose the olivine, right? So olivine is formed, it is removed, right? And then those are melt will be reached in silica, right? So the little phases like amphibole or biotite, it will be formed. So it will be come down the andesitic type of magma, right? So where the set of minerals will be amphibole, right? So and biotite and intermediate plagioclase and also sodium rich plagioclase. Plagioclase. So then further, if these form minerals, this discontinuous series, so those are removed, then the remnant mill will automatically become rich in silica, right? So and the only element left will be potassium. You see here potassium and right? So initial melt was, it is very high in silica, and there are very rare chances that we'll get a free form of silica in terms of quartz, right? This quartz. So I hope you understand that how we can switch from basic to acidic magma, right? Basic to acidic. This is basic and acidic. So those are magmas by doing some of the modifications in between, like it removing some of the early phases. But we don't remove the early phases. So the minerals are constantly in contact with the melting. Then we will form the minerals like olivine, pyroxene, calcium rich plagioclase, and no quartz sheet, right? So because in case of mafic magma, where the silica percentage is only 45, right? 45 to 55 percentage. So there are no chance that it can form the free quartz, right? So we can say olivine and quartz, olivine and quartz. So these are highly incompatible minerals, and we cannot see these two, olivine and quartz minerals, are all together. So you see here more resistant, right? Wait. Okay. You see here more resistant and less resistant. Okay. You see here less resistant and more resistant. So more resistant, it means these minerals which are low in temperature. You see here low temperature, right? So these are not vulnerable to weathering. So they will weather last while. So the minerals which are high temperature minerals, so they are not stable at the surface of the earth. So there will be easily decomposed, or there will be easily breakable, and so these are the less resistant minerals, right? So these are the high temperature, that is 1400 degrees, and this is low temperature, those are felsic, acidic, more resistant minerals. So and this is the order of formation of minerals. and this is the order of minerals here, right side, sorry, left side, right? So which they can easily be weathered. So this was all about the Bowen reaction series. I have mentioned some of the minerals relative to continuous branch and discontinuous branch. Right? See here, continuous reaction branch that is composed of the plagioclase feldspar solid solution series, right? So a basaltic magma, it will be initially crystallized in calcium and rich plagioclase, and upon cooling it will continuously react with the liquid to produce more sodium rich plagioclase minerals. And if the early forming plagioclase were removed, then liquid composition could eventually evolve to a rhyolite liquid. So that would crystallize in a sodium rich plagioclase, right? So this is the continuous branch, and discontinuous branch. This series consists of minerals that upon cooling eventually react with the liquid to produce a new phase, right? So this crystallization of olivine from a basaltic liquid, it would be eventually reach a point where olivine, it would be react with the liquid to produce orthopyroxene. So with further cooling pyroxene, it would react with the liquid. So the melt becomes more enriched in water, that is to produce hornblende, right? So during further cooling hornblende, it would be react with the liquid to produce biotite, right? And if the earlier crystallizing phases, those are removed before the reaction with liquid, it can take place when silica content of remaining liquid, it will be eventually. So this is the Bowen's reaction series. So you see some of the pictures, and this is low temperature minerals and this is high temperature minerals, right? So process by which minerals are formed and removed from the molten rock. Right? So I think you see here some of the examples and figures, right? And also here, okay. Okay, right. So I think all of you understand this Bowens reaction. So I will explain once again, right? So we have actually two parts of that is two. There is the discontinuous series, and on the left side that is continuous series, right? So in the discontinuous series, at a very high temperature, you see here high temperature. So the first mineral to form is olivine, right? So, but as the magma continues to cool, so some of the olivine, it will be turned into pyroxene, right? So, if we remember the pyroxene that you are familiar with is agate, right? So, agate as the cooling continues. So, that pyroxene will turn into amphibole, right? So the last part of the discontinuous series, the amphibole, this amphibole, it will be turned into biotite, right? So that is official, the end of the discontinuous series. So however, sometimes the magma, it has not finished cooling down and there is still plenty of liquid left, right? So this liquid that is left um, through as that aluminum, right? Aluminum in it. So it can make it K feldspar means potassium feldspar, right? Or it could make muscovite also, right? Muscovite mica. Or if it has lots and lots of silica, right? So it could make quartz also, right? So hence the discontinuous series, this discontinuous series, at the same time, this continuous series is going on. Remember this, right? Same time, this continuous series also going on. So it starts off with the first mineral forming of this calcium rich plagioclase. And now calcium rich plagioclase is a kind of gray color, right? Gray color. So it is happens, it is to be called anorthite. So as the melt, it cools down the calcium that is booted out of the plagioclase, this plagioclase, and replaced by sodium rich, right? So if there is enough sodium to boot out the calcium, right? This calcium by the end of this continuous series of the Bowens reaction series, it is all sodium rich plagioclase. So, and then of course, extra silica and extra aluminum, right? And such are all going into making the potassium feldspar here, potassium feldspar, muscovite mica, and quartz. So you are starting high temperatures olivine, pyroxene, amphibole, and biotite. So you have remember this order by going OPAB. So OPAB, right? OPAB. So this is the Bowens reaction series, right? So Bowens was experimenting with what happens if you take a mafic igneous magma that is completely liquid and allow it to cool slowly. So he discovered who Bowens. So Bowens discovered that a mafic magma, as it cools it does not cool. And freeze like water, remember, different minerals are crystallizing out of this melt. So where water freezes at 0 Celsius, right? Here, 0 Celsius to ice or ice melts at 0 Celsius back to the water as the temperature rises. That is, magma cools over the temperature ranges. Mafic magma, those are erupts at the surface temperature, that is ranging up to about 1400 degrees. See here, 1400 degrees Celsius, or down to about 1200, right? 1200 degrees Celsius. So typically, if you have a mafic body in the crust cooling, it will cool through that range down to our final freezing temperature for the last remaining bits of melt quartz and feldspar. That is reached down around 650 or 700 or 800 degrees, right? Celsius. So that is during the cooling process, a series of different sorry, minerals crystallize out. This is what we call Bowen reaction, right? So Bowen realized that this is essentially what happened in nature when a mafic igneous, sorry, that is mafic igneous intrusion, right? Intrusion. So that is the plutonic of magma in the crust. As it slowly cools, it might erupt originally mafic igneous rock like basalt, right? You see this basalt. So, but as the time goes on and it cools in the crust, where it coolest is gone be around the margins of the magma chamber, and so you will get minerals beginning to crystallize. So inward, almost like it. So it's a massive geode, although the crystals are of course, it is very small, right? So you get the crystals large enough for you to see it for visual clarity, but they are just normal grain sizes. But the this magma chambers that pulls olivine and pyroxene, right? So it will start to play out over the olivine and around it, right? So this is the Bowens reaction series. So this is the important question in your examination. Okay, today class is over.